Welcome to part 6 of playing Breakout with deep reinforcement learning. Today we are going to go ahead and code in the test function for agent.py here, and then we're going to start tying it all together. So in the last video we did the train function, and that actually contains the training loop. In this video we're going to go ahead and do test. So we're going to say def test, and what the test method is going to be for is so we can actually run something that's going to pop up on our machine and show what this thing looks like. So let's go ahead and start coding. It's going to take self, and it's going to take an environment, env, and this is pretty simple. For epoch in range 1, 3. So we just wanted to play through 3 times. We're going to say state equals env.reset. Done is false. And then for underscore in range, remember, use underscores in Python when you have a throwaway variable. And we're just going to say 1,000, so take 1,000 steps. Time.sleep 0.01, and we're doing this so we can actually see the thing run. By default it's going to run very, very quickly, so just having it sleep for 1/100th of a second for each step helps it run a little closer to human timescales. So then, and I see that we do not have time imported. We'll fix that in a moment. So I'm going to say action self.getAction, and we're going to pass in state. Then state reward done info equals env.step action, and if done break. And that's all we have to do for the test function. Like I said, it's pretty simple. Up here at the top, we are going to go ahead and import time. Go ahead and import time. And then we can go ahead and move back over to our main.py. This is where we're going to see if I've forgotten anything. Very good chance I have. So we don't need most of this. So right after model.load the model, we're going to go ahead and declare our agent. And we're going to pass in a few things. So we're going to pass in model equals model. Device, oh, and I don't have agent loaded. So we're going to say from agent import agent. So back down here, we're going to say device equals device, which if you recall, we set that to our GPU. We're going to start off epsilon at 1.0. We're going to do NB warmup, which is our warm-up steps, at 5,000. So that's the time it takes for epsilon to decay from 1 to the minimum epsilon value. That's what we're doing there. We're going to say NB actions is 4. That's the number of actions you can take in the game of Breakout. Learning rate, I found that having this relatively low was necessary to get really good at the game. But when you're first starting out, you want to set it right around there. So 4 zeros and a 1. And then as the agent gets better, you do want to decrease that. And there are ways to decrease it with code. I just ended up decreasing it manually for this exercise. And I'm going to say memory capacity is, we're going to set that to 1,000,000, so it can maintain 1,000,000 previous steps. And we're going to set batch size to 64. So that is our training batch size. And let's go ahead and run this just to make sure we don't get any errors on declaration. All right, and no waits file, that's fine. And process exited, cool, so it did what it was supposed to. we're going to do agent.train and env equals environment. Epochs, let's just say 200,000. That's going to take a while. And that's probably a really good place to go ahead and try to run this again and see if our training loop works and does its thing. Okay, so our training loop is working, but that is not going to work for us. We don't actually want this thing to display on the screen like it is, because this is going to take a really, really long time to actually do any sort of training. So I'm going to exit out. Let's go take a look and see what we did wrong. Oh, I think I see it. So up here, when we were playing with the environment earlier, we said render mode human. So we're going to undo render mode human, and we're going to try it again and see if it picks up and starts training. Okay. It's thinking about it. Aha. And we have blown up successfully. Okay, parent directory models does not exist. So we've got some code in here somewhere that is creating models, and that is over here in save the model. So there are a couple of different ways we could handle this. Obviously I could just come in here to the IDE and I could, create the model that we need, and that would work. But let's go ahead and just let's go ahead and create our directory in code, because I would much rather have, just as a best practice, I'd rather have the code provision the environment it needs to run. So I'm going to say if not os.path.exists, exists, and we may need to import OS up here. Import OS. So if not os.path.exists, and we're going to say /models. We'll just do models. I don't think I need the / here. os.makeDirs models. Okay. And then we also want to maybe see about getting a little bit more output, because I think we are missing some of the output that might have helped us see, that something was running here. So let's think about where we might want that output to exist. Let's come down here. So if epoch, so we have this, if epoch %10 modulus equals 0, it should be printing out. Okay, so maybe it just didn't get to, that's exactly what happened. It ran save the model, it crashed, it never got to our output here. So we're just going to try that one more time. All right, and we have started training. Epoch 10, episode return, -5.0, and it's giving us our epsilon readout. So that's saying that right now it's taking almost entirely random actions, and it's getting negative results. So from experience, this can take easily up to 1 million iterations to train. It took me about a day and a half of continuous training with this methodology to get this model up and running. So obviously we're not going to sit here and watch this run. This is something I encourage you to do. But I'm going to go ahead and kill this, and we are going to go put together our train script, so I can show you how to actually test your model once it's trained. And then in the next video, we will do some statistics graphing, just so you can kind of see, what your model looks like as it's training, and then that will conclude this little mini-series. So let's go ahead and put together our Python test.py, and you could do this a few different ways. I chose to make main.py my training file and test.py my testing file. So we're going to come over here, and I'm actually going to be very lazy, and I recommend you do the same. We are going to copy everything in main.py over to test.py, and the only difference that we're going to make is here where it says agent.train, we're going to say agent.test. And this is where I said you could do this very differently. You could have had main.py take arguments. You could have had several different ways to handle this. I chose to handle it just as a different file. So I'm going to go ahead and run current file. Oh, and it didn't like the fact that I passed an epochs, because the test method does not take epochs. Okay, that finished, but it didn't display anything. I think we need to go back. This was a fix earlier where we said we did not say render mode was human. So we need to put that back. And render mode is basically just telling the environment, hey, am I going to display this to a human, or am I just going to return machine readable output? That's what that's doing for you. So again, we're going to try this one more time. And hey, we have our testable, very, very poorly performing model running around doing random things. So this is a great place to stop this video. Again, at this point, you should have everything you need to actually start training. In the next video, we are going to go ahead and fill out this plot method, and this plot method is just there to start giving you some training numbers over time. When you start experimenting with different parameters and different training methods, it's very, very useful to be able to see sort of what those trends are. Earlier we showed some output down here in the IDE, and that's really useful. That can tell you what your current score is. But if you've had to walk away from your training for 10 hours, you probably want to know, has it been going up for 10 hours? Has it been going straight down all 10 hours? Have you had a wave the entire time? That information starts to build a little bit of a picture of the environment. So there are a couple different ways to get that picture. Well, more than a couple. There are many ways. There are a couple I've used. One of them is TensorBoard, which is a little bit more setup than I want to get into right now. The other is what we're going to do, which is using matplotlib to write a file out for for our training data. So anyway, that is the next and last video, and I will see you there.